Hello everyone, welcome to the Electron Flow Academy. So, after understanding the concept of the series RL circuit, okay, so our next topic is the response of the AC circuit while connected across the series RC circuit. Okay, so here consider a circuit having a resistance R and the capacitance, or we can say that the capacitive reactance, which is XC, in series across the AC voltage source. This is our AC voltage source, voltage V, and let the resulting current is capital I. Okay, so this is we have considered the condition here. So as we know that the voltage drop across the resistance is given by V of R is equal to IR. Okay, so if I draw the phasor of this, we know that in the case of the pure resistance, the voltage is in the same phase with the current. So this is our voltage of VR, okay, in the same phase with the current in the case of the pure resistance. So we are talking about the VR here. Okay, next thing is that the voltage drop across the capacitance, which is given by V of C. So V of C is equal to I times XC. Okay, so this is the lagging the current by 90 degree. Okay, so lagging current by 90 degree. So if I draw the phasor diagram here, so this is our current I. So from the current, the 90 degree apart, 90 degree is situated the VC. Okay, so since it is the series circuit, so the current capital I is taken as a reference. Okay, this is our reference. Okay, so next thing is that here we need to apply the KVL. To apply KVL, the applied voltage capital V is equal to the phasor sum of the VR and VC, but the drop of the VC is 90 degree behind, as we seen here, 90 degree behind the VR. So the J operator is used with the negative sign. So after applying the KVL, we have the equation for the voltages. Total voltage is equal to VR minus J of VC. Okay, so this is our equation number 1. Okay, so the phasor diagram of these equations gives the voltage triangle. So the voltage triangle will look like voltage triangle. This is our reference current I. Okay, and this is our V of R. So from the V of R, 90 degree apart, situated the minus of J VC. Okay, so the total voltage is the resultant of the both. Okay, 1 minute. So the total voltage is the resultant, which is starts from here. Okay, at an angle of 5. This is our resultant voltage. So this is how we write this equation. V is equal to VR minus J of VC. Okay, so this is our voltage triangle. So from the voltage triangle, it may be observed that in the series RC circuit, current I leads the supply voltage V by an angle phi. where phi is the power factor angle. Okay, here phi is power factor. Okay, so from this voltage triangle, we can rewrite that from voltage triangle, we can say that tan of phi is V of C divided by V of R. Okay, so again, here phi is equal to now tan of inverse multiplied by V of C divided by V of R. Okay, so this is the leading. So from the equation number 1, from equation 1, we can write that voltage is equals to IR, which is the VR, value of the VR, minus J time I of XC. Okay, so by taking common the current, I will get V divided by I is equal to R minus J of XC. Okay, and the ratio of the applied voltage V, this is the applied voltage V. So the ratio of the applied voltage V to the resulting current I is the impedance of the circuit. Okay, so it may be regarded as the combined opposition of the flow of the AC current. So I can write here the ratio of the V to the I is nothing but the Z, which is the impedance of the circuit, is equal to R minus J of XC. Okay, so this is our equation number 2. So from the equation number 2, here, from equation 2, which is Z is equal to R minus J of XC. Okay, this equation gives us the impedance triangle of the series RC circuit. So impedance triangle of series RC circuit will look like this. This is the value, this is the phasor of the resistance R. Okay, and this is the 90-degree apart minus J of XC. Okay, and this is our reference point. The resultant is impedance Z at an angle of phi. Okay, so this triangle is known as the impedance triangle. So from this impedance triangle, I can find out the tan of phi is equal to nothing but the XC divided by R. Okay, so the value of the power factor is now, or power factor angle is phi, which is equal to tan of inverse XC divided by R. Okay, so here we know that the value of the XC is equal to 1 upon omega C. Okay, or we can rewrite this xc is equal to, we know the value of the omega is 2 pi f. So 1 divided by 2 pi f time c. Okay. So here the c is in farad. Okay. And f is frequency in cycle per second or in hertz. Okay. So this is how we can understand the impedance triangle of the series RC circuit. Okay. Now next thing is that the power and the power triangle. Okay. Of the series RC circuit. What will be the power and the power triangle? So we have seen that in the series RC circuit, the current I leads the voltage by an angle of phi. Here we have seen that the current leads the here current leads the voltage by an angle of phi. So therefore, if we take capital V voltage as a reference, we may write V is equal to Vm sin omega t. Okay, and the current is equal to Im sin omega t plus phi. So what we have assumed here, assume that voltage is as a reference. Okay, so we know that the instantaneous power is, so power P is equal to V of I. Okay, so putting the value of the voltage and current, then we will get Vm sin omega t into sin omega t plus phi. Okay, so let's further solve this equation like, sorry, V of m Im divided by 2 multiplied by cos phi minus cos 2 omega t plus phi. Okay, we know that the sin square theta is the cos 2 theta divided by 2. Okay, so if I talk about the average power okay, the formula of the average power is 1 upon periodicity, which is the 2 pi integration of the 0 to 2 pi of power. Okay, P d omega t. Okay, so here we need to calculate the average power. Okay, so average power will look like, okay, P is equal to 1 upon 2 pi, putting the value of the power, which is this power, in the equation this. Okay, so put this value here and integrate it. Okay, so 1 upon 2 pi 0 to 2 pi Vm divided by 2 cos pi minus cos 2 omega t plus phi d omega t. Okay, so this is our equation. So after solving this equation, I will get the value is Vmin divided by 2 cos of phi, or I can rewrite this equation like Vm by root 2 into Im by root 2 cos of phi. Okay. So here the value of the average power is equal to, we know that the maximum value which when divided by the root 2, that means it's a RMS value. So this is the Vm by root 2 means RMS value of the voltage, and Im by root 2 means RMS value of the current multiplied with the cos of phi. This is our average power. Okay. So this implies that for a given voltage in the current, power consumed depend upon the power factor of the circuit. Okay. So uh, from voltage equation, okay, so voltage equation, we know that we discuss voltage equation here. This is our voltage equation number 1. Okay, this is our voltage equation. So from the voltage equation, which is equal to V is equal to V of R minus J of Vc. Okay, so from this equation, we can put the value like voltage is equal to V of R, meaning here V cos phi minus JVC means J times V sin phi. Okay, so here we have elaborated the voltage equation with the help of the voltage triangle. So in this equation, multiply the equation with the both sides. Okay, multiplying by current I. Okay, so after multiplying the current I, we will get V of I is equal to Vi cos phi minus J Vi sin phi. Okay, so we know that the multiplication of voltage and current is equal to nothing but the apparent power, which is denoted by the capital S, and Vi cos phi is nothing but the real power, which is denoted by capital P, minus Vi sin phi is nothing but the reactive power, which is denoted by the Q. Okay, so this is the equation of the power. Okay, so this is the equation of the power. Now we need to define the power triangle. Okay, so from this equation, from the equation, 1 minute, from equation S is equal to P minus J of Q. Okay, this equation gives the power triangle of the circuit. Okay, so the power triangle will look like this. This is the real power P. Okay, in the case of the RC series circuit, the reactive power situated 90° apart, minus 90° apart from the real power. Okay, and this is our the resultant of the apparent power S, which is phi angle apart from the real power. Okay, so this is our power triangle. So this is our power triangle. Okay, so in the power triangle, we know that S, which is equal to Vi, is nothing but the apparent power. Okay, next we know that S is equal to apparent power is also equal to I square Z. Okay, or this, and P, which is equal to Vi cos of pi, is nothing but the active power or real power. Okay, so we can rewrite this, or P is equal to I square R. Okay, and third thing is that first, second, third. Third is reactive power Q, which is equal to Vi sin phi, which is nothing but the reactive power. Okay, or Q is equal to I square XC. Okay, so it may be noted that in the case of the series RC circuit, the reactive power is negative. Okay, so this is negative in the case of the series RC circuit. So negative reactive power can be in, interpreted as a leading reactive power consumption. Okay, so overall, if I talk about the summary of the results for the series RC circuit, so first we can check, we have calculated the voltage equation. Secondly, we have calculated the or find out the impedance equation, and last we have find out the power equation. So if I talk about firstly the voltage equation, so which is equal to V is equal to VR minus J of Vc. So the voltage triangle is look like this. Okay, so here we assume that the current as a reference. So from the current, the minus 90-degree apart is minus J of the Vc. Okay, so the resultant, which is the total voltage, which is apart at an angle of the 5 degree. Okay, so the power factor means in the series RC circuit, current always leads the voltage by an angle of the 5, which is called the power factor. So if we want to calculate power factor with the help of the voltage triangle, then the power factor is equal to VR divided by V. Okay. Secondly, if I talk in terms of the impedance equation, so we get the impedance triangle. This is our impedance triangle. Okay. So in the case of the impedance triangle, if I need to calculate the power factor, then the power factor is equal to cos phi is equal to R by Z. Okay. And lastly, the power triangle, which we have achieved with the help of the triangle equation, which is equal to S is equal to P minus JQ. So if I need to calculate the power factor from this equation, so the cos of phi is equal to the P divided by S. Okay. So this is the overall summary of the series RC circuit. So thank you very much. Kindly like and subscribe our channel.